Hello there, it's ShayDB, and today I'm going to be walking you through the code used to design our photo booth by STB Computing. And then we're going to take a look at the diagram examining the physical components that we use for the photo booth. So as with any Python project, we have our lead developer, our title, and our date marked at the top for documentation. We have our importing of different modules that we used within the code. So obviously we don't need to import more code than we need. So we just imported the required code for all of these. We have all of our inputs and outputs here marked out. So we've got a light sensor, buzzer, motion sensor, pi camera, distance sensor or rangefinder, 3 LEDs, and a button. Next, we have a function here that will take a picture. Depending on the light level, it may simply take the picture and add our own stylization, as well as marking it out where we want to locate it and noting it with the date and time. Or if it's too dark, we'll also add an effect layer over top so that it is going to look a little brighter and have a better result for our fans to take home. We have a little intro logo that's going to pop up when you first turn on the machine for the admin. And then we've got some login info. So we've got a little counter here that I'll get into in a minute. And then we have a list of users. So we can always add users depending on who's employed by the particular stadium to boot this up. When it's turned on, this is the first executable line of code. So it will print out the intro. So it will print out this lovely little overlay or this lovely little text block. Then when true, so this is our login loop, it will print 1 out of 4 available attempts, give the admin an opportunity to enter their username. If this guess or their username input is in users in that list from earlier, it's going to print welcome system activated, photos may now be taken, and our green LED will begin to blink and then we'll be able to move on. If it's not in users, we will add a tick to the counter and then go back to the start of the loop, offer another opportunity after telling them that that user is not recognized. If more than 4 attempts have been made, we are going to print access denied, as it's probably someone fooling around with it who shouldn't be. After the login, there's going to be a 5-second sleep period to allow people to get out before we actually start up the system. Then, when guests go to get in, it will trigger the motion sensor, and then it will print Welcome to the Inter Miami MLS FC photo booth. To start taking your picture, please press the button. Guests will press the button, enter some of their details into the different variables that we have here with inputs. That way that their photo can be sent out to them following the game. It will print, please press the button again to continue. So we let them get settled, press the button, and then it's going to give feedback depending on how close they are. So if they're sitting at the right distance, that's our middle elif statement here, it's going to tell them to please hold still photo commencing. If they're too far away, it will tell them to move closer. If they're too close, it will tell them to move away from the camera. Then we'll get a countdown light sequence. So we'll turn off that blinking green LED from earlier. Then we'll turn on the red, then the yellow, then the green. Once that turns off, the picture will take, our buzzer will go off, and it will print photo complete, thank you and enjoy the game. Just a little bit of friendly customer service there. So we'll look over the wiring here now as well. So I'm going to work through in the order of the notes just to make sure that everything is sensibly laid out. So our blue wires here are connecting our 5-volt power up to this horizontal rail and our 3-volt down to our horizontal rail, as well as both ground rails to ground points. Our red wires are all connecting to our PIR system, so that's going to ground it, it's going to give it 5-volt power, and it's going to connect it to GPIO 24 in order for it to be controlled. Our light sensor is this lovely little red one over here. The signal line is running to GPIO 22. Our ground runs to ground, and our VCC runs to 3-volt power. Our yellow wires are our buzzer, so that runs from GPIO 23 up to the buzzer and then down to ground, so that will trigger when we want it to. The green is our distance sensor, so our VCC runs down in here to our power source. Our trigger is going to come down here to our 17. Echo runs to 18, and our ground, of course, is going to run to a ground rail. Our white is our LED hookups, so that runs from GPIOs 13, 16, and 19 to resistors over here as documented. The resistors each connect to a rail that connects to the LEDs, which then connect on into a ground rail of their own. Then we've got our gray, our ground to our button, and then our button running back up to GPIO 26. Unfortunately, we're not able to add in the actual Pi camera and Raspberry Pi, but they will be connected via ribbon cable here to the board, and then the board connects to the camera. And that's everything with our lovely new system. So hopefully you will decide to purchase and enjoy this lovely system. Thanks. Bye.